One of the most important industrial protocol, industrial data communication protocol is DNP3. DNP stands for Distributed Network Protocol. It was originally created by Westronic in 1990s. And in 1993, DNP3 Basic 4 version was released, and from then on, everybody knows it as DNP3 protocol. So in this particular lecture, we will be discussing about how this protocol works, what is the application of this protocol, what is the frame structure, what is the different function codes used in this protocol. So as I said earlier, DNP3 stands for Distributed Network Protocol version 3, and this particular version is being widely used in United States electric utility industry, and also this is the basis for European IEC 60870-5 standard. Aside from this serial version, there is a IP version that is being used. For the IP version, port number 20,000 is being used. So DNP3 was basically designed to be a protocol for reliable communication between the SCADA master and remote RTU. And most recently, it has become a commonly used protocol for communicating with intelligent electronic devices such as protective relay and other common electrical substation equipments. So these two areas are basic application of DNP3. Now, there are various modes of communication in DNP3. In DNP3, the communication happens between a master and a remote. Remote is also known as outstation. So there can be polling with full reporting, there can be polling with priority, there can be polling with the subsets of data, and there is also an option of unsolicited response or unsolicited exception reporting, which means that the master and remote has now multiple option of communication. Remote can provide the whole set of data, or it can provide also a subset of data. So this concept is very important from the point of view when you have a low bandwidth range and you have to communicate with multiple remotes. In that scenario, if the polling goes on automatically and remote also sends data and whole set of data, then what happens is there is a collision of communication occurring in the low bandwidth channel. Instead of that, DNP allows us to send a subset of data, which means only if your value is changing, that changed value will be given to the master. But if there is no change in value, data will not be given to master. So what all different type of communication is available? So if you have a master, there is basically a master and a remote, and master can request data from the remote. Remote may be busy at the time and say, "Hi, I got your message. This is my confirmation. I am sending data after some time." After some time, remote responds to the request and sends the data. Obviously, master can give optional confirmation. And obviously there can be NAC command also available when there is an error in the transmission. Again, remote can send data without master asking for. It can send unsolicited response. So this is, and master can give optional confirmation to it. This is particularly very important because now remote can send data even when the master is not requesting it. So this can be related to uh, health of the RTU or any emergency alarm that it wants the master needs to know. This helps us to really communicate faster, because what happens normally, this communication, this SCADA and the remote RTU, they're placed in the pipeline, and the pipeline may be ranged over a thousand of kilometer, and there are number of RTUs in between, and every RTU, when it communicates to master, so the polling occurs, and maybe after 2 minutes or 5 minutes of time, and the same remote get a chance to send the data to the master. Now, with the unsolicited response, the remote can send immediately data to the master, and this gives a more chance for the response, right? So this is particularly important for the critical industrial application where uh, the early response from the remote terminal can help saving dangerous situation or dangerous calamity. So that's why the DNP3 communication is very popular um, in the industrial sector. So this is the frame structure. As you can see that there can be total 292 bytes of data that it contains in its message, and this is the frame header, which is 10 bytes long, and the data portion is around 280 bytes, and after that there is frame CRC. Now there is an option that this whole data can be sent together or they can be broken, right? And for each block there is a block CRC and there is a frame CRC also. So if you see, there is a lots of CRC checking that is happening on the data being transmitted. In the frame header gets a CRC, each block of data gets a CRC, and overall frame also gets a CRC. So it should be nearly impossible that a bad data goes undetected with all of that error checking. It may seem excessive, but a single flipped bit can cause misoperating of a circuit breaker or misoperating of a valve, and that may cause blackout of a electric grid, of a large portion of the electric grid, or loss of containment from a pipeline, or misoperation over pressurizing the line. So that's why, as this app protocol is particularly used for a typical critical industrial application, there are lots of CRC check that is required. Again, if you see that you have an option that you can break this 280 bytes of data in the link layer to small pieces, and there can be total 16 block is possible, and each block have maximum of 18 byte of length, right? So, and then it 2 bytes for the CRC and 16 byte for the data. So as a result, the last block have only 10 bytes of data. So this is the overall frame structure. Now The application layer consists of 27 basic function code to exchange the data and commands between the master and remotes. Some of these function codes enable a master to request and receive status info from the remote. Other function codes enable master to change remote setting. There are function codes defined in DNP3 to control the remote devices like circuit breaker, transformer, pumps, valves via remote. This could be via physical I/O of the remote or via communication link between the remote and the smart devices. There are function code to enable remote to respond with an unsolicited message to events or condition it has been programmed to monitor or detect. Most of these messages are issued by the DNP3 master because the unsolicited message is capable of being initiated by the remote. It is typically used to report alarms. This notifies the DNP3 master as soon as alarm condition occurred, instead of having to wait for the next pole response request from the master to that remote. So this is the DNP3 model of the data communication. Hope you have understood it. If you have any doubts or any query, you can write in the comment. Thank you.